I like learned programming in Python when I was 10 and just fell down the rabbit hole. Things like this. And I would do odd jobs for people. I'd like code up an NFT contract for someone. And through one of these servers, a bot sent me a message that had a private key, 40 USDT, 0 ETH. And so the trick with this kind of honeypot scam is that you send in ETH so you can transfer the USDT to your own wallet. But the scammer, who still has the private key, has a sweeper bot running who takes that ETH and sends it back to their own address. And so I looked at the public key for this private key and the address, and this probably tricked like 10 people. And so I was like, well, it's not going to get me. In probably the next 2 or 3 weeks, I coded something up using some Flashbots repositories and some pretty basic Python scripting, and it worked. And I stole 40 USDT from a scammer.
Based rollups are incredibly based, and in this episode, we're going to talk with M-Team from Spire Labs all about it. We're going to talk on how based rollups are better than traditional rollups. Me and him both agree based rollups are cool, but we're going to get into a little debate around based rollups on Ethereum versus Celestia and Pre-confs. And before we get into all the based rollup stuff, M-Team is 17 years old, so we're going to talk about his backstory and getting into crypto. Anyways, let's get to it. Based rollups. Why?
Dude, there's a lot of problems with deployment options for applications today. And the problem that base rollups solve is that none of these deployment options are composable with each other. So Ethereum layer 1 is kind of the golden goose. Everyone wants to be on layer 1. It has the most TVL, has the most kind of unique applications. And what a lot of people don't realize is that Ethereum has just a massive amount of network effects. So if you're doing that kind of cost benefit analysis and looking where do you want to compose, you want to compose with a layer 1. The problem with that is that it's not easy to compose with layer 1. And in fact, the only good way to do it that exists right now as we speak is by deploying a contract on layer 1. And then obviously you're composable with Ethereum because you are on Ethereum. And base rollups kind of add an abstraction layer on top of that smart contract on layer 1 that has its own sequencing. It's like a full rollup. You can customize your execution environment. You have isolated state, so you're not kind of sharing fee markets with other applications. And what that enables is the users and developers to have their own special app chain, or just general purpose base rollup even, but still be composable with layer 1. So the tech is not ready right now, but in a few months we'll have something called synchronous composability, which means that we enable cross-chain contract calls with Ethereum layer 1. And so that means that every existing contract on Ethereum layer 1 will feel like it's already on your app chain, and vice versa. Every contract deployed in app chain feels like it's on layer 1, except that for only app chain users, you have much cheaper costs. You have the ability to kind of customize certain things about how your app chain works. Maybe you want account abstraction before Ethereum layer 1 adds that. You can do that. And then you can change all sorts of other things about your app chain, so your block times, whatever. And all of these combined give the developers a really great developer experience because you don't have to deal with like message passing or asynchronous composability, which is just complicated. You can literally just write your application as if it was on layer 1, copy and paste it to layer 2, and it feels the same. I think that's probably the single greatest benefit. And then for users, you're just getting cheaper gas fees, and you still get to use the Ethereum layer 1 that you know and love. And so, I mean, I firmly believe that if we knew about base rollups and we knew that ZK would be this far forward, then we would just be building base rollups from day one. Like, there's no reason to do a centralized sequencer if you can do a base rollup with some of the kind of the quirks and twists that we introduce.
Yeah, so I'm a base rollup enthusiast as well. I have different takes, mainly on Celestia. My sort of take is base rollups are sort of cooler and better on Celestia land, and I have like more opinions on that. But before we get into like the debate and sort of explaining base rollups, like you're 17, like can you just like intro yourself first, sort of how you got into the industry, your like MEV story, and then just unpack that first. Like I'm still like amazed.
Thank you. Yeah, so my background's not even that complicated. I like learned programming in Python when I was 10 and just fell down the rabbit hole. I can't tell you like exactly why I enjoyed that, but I did. and it was fun. And so I spent a lot of time in like the for my first intro to crypto, I should say, is like trading NFTs in whatever cycle that was, and that was interesting, I guess. I sold some NFTs, but then I that's how I learned about like Solidity because I was like, how can I customize my NFTs so that they do all these other things? And I learned about writing smart contracts. Did that for a while, um, just messing around. Didn't deploy anything to mainnet, and then eventually I um, I guess I became accustomed to kind of the blockchain paradigm of just having money that anyone can use. And for someone who was 14 at the time, being able to send money, use finance without a bank account, without asking my parents was amazing, right? That was the real unlock for me, is that censorship resistance, permissionless kind of quality. And so I wanted to take this and put it to good use, to put these skills to good use. So I would hang out in Discord servers for like Solidity devs and things like this, and I would do odd jobs for people. I'd like code up an NFT contract for someone, just kind of doing freelancing work. And through one of these servers, a bot, I'm sure, found my Discord, sent me a message that had a private key. It was Ethereum layer one, 40 USDT, zero, zero ETH. And so the trick with this kind of honeypot scam is that you send in ETH so you can transfer the USDT to your own wallet. But the scammer, who still has the private key, has a sweeper bot running who takes that ETH and sends it back to their own address. And so I looked at the public key for this private key and the address, and this probably tricked like 10 people. And so I was like, well, it's not going to get me. I did some research. I like asked some Stack Overflow or something, and someone directed me to Flashbots. So I learned about bundles and how you can kind of have two actions be atomic. So then you know, in probably the next 2 or 3 weeks, I coded something up using some Flashbots repositories and some pretty basic Python scripting, and it worked. And I stole 40 USDT from a scammer. Um, and that was kind of my first intro to MEV, and it hooked me, right? So like that kind of $40 is a lot for a 14-year-old, and so I I got introduced to this idea with like a clear financial incentive, and that was enough to send me down the rabbit hole. So I joined the Flashbots Discord. I spent a long time there, learning, kind of lurking and writing. And my my I guess my breakthrough was meeting Justin Drake. And Justin's a great person to know in crypto, by the way. He can get you connected to anything. Um, and so I got kind of onboarded from MEV to Ethereum research, and I spent some time doing that. Now started a company. So yeah, I mean, that's kind of a little anecdote from my background, but the real reason I'm here is to disintermediate all human coordination. And the reason I think that's interesting because it's the only thing that blockchains can do better than centralized systems of trust. And people try to express this in different ways. I like the phrase "eliminate the middleman," um, with the goal of removing intermediaries at every stage of human coordination. So that's finance, social, gaming, entertainment, creation, so on and so forth. Uh, you go down everything that humans do together, and there's an intermediary, and that pisses me off. And so removing those intermediaries, or kind of decentralizing them, is kind of the reason I'm in crypto.
Yeah. I was also one time 17 in crypto. I got into it when I was like 15 years old. Same cycle as well. Early 2021. Did you ever program an NFT project? Quick question.
I did.
And I think I remember you. It was some guy on Telegram was like, is the dev a 14-year-old? And then were you the person who said, is that a problem? And then like,
I
yes,
think that was me.
no,
Maybe I doubt it.
maybe. I remember like a long time ago, there was like this like buzz around the NFT dev being a 14-year-old, and then whenever questioned was like, is that a problem? And so I'm like, that might be you. Anyways, I think before we get into the base roll up stuff, uh, so do you see any young people getting into crypto? I know like Zoomers don't like crypto at all, and AI weirdly enough. And so I thought you were like from the bear market, but you're still from like 2021 cycle. Do you see like younger people getting into crypto anymore, or like what's up with Zoomers?
Yeah, I mean, I've onboarded a couple of my friends. I still think crypto is like a nerdy thing. Like talk about Bitcoin, that's like people's first reaction. But I hope that changes at some point. I think people I mean, the honest truth is that young people just don't care about finance nearly as much as older people. They don't care about money as much. And so I think that crypto, which is like a hyper financialized industry, will always kind of have a culture around finance, around money. And that's something that people who are young just try to avoid, right? They want to spend time with social interaction, like on social media, perhaps, rather than doing finance. But the younger people that I know um, that are really locked in, they're uh, and have an interest in finance, perhaps because they want to make money or just because they think it's interesting. They are deep in crypto, right? Like it's hard to find someone who knows things about the stock market but doesn't have an interest in crypto. And so that's what I would say. It's like there's a divide between these two groups.
Hmm. And I guess another question is so I was also sort of in the 2021 cycle, got into crypto. For me at 17, like I absolutely loved consensus protocols and like Tendermint. Like that was like the rabbit hole that I went to deep inside the pandemic. I guess you already talked about your MBV story, but like and I didn't finish high school. High school was online during that time. So I kind of like cheated in class and then would like do crypto stuff and would have to like, after after cheating for like 2 weeks straight on online high school, I would like go forget about school and like do my crypto like degen stuff. Uh, do you go to school? And I had a not finishing high school. Like at 17, I had like this internship and I was like traveling. I went to Rio, Ethereum, and Avax, Barcelona. So like Spain and like Brazil. And then afterwards, some guys like, why haven't you? Aren't you supposed to be like at school? And I'm like, yeah, I'm 17. And I was like, I do it online. And like after that moment, I was like, you know what? Like I'm not doing anything else in my life. I'm gonna like go all in on crypto. And like I never finished school. So like, what's up with the school situation?
I am still in high school. Yeah, I went to high school today. I think there's a chance I leave. I don't know. I it's the workload is not even that bad for me. Like I can usually finish things like homework in in the school day or maybe a little bit afterwards, but it's not too bad really. And I like being able to spend time with people in person. But
Yeah,
we'll see.
no,
I
I
traveled
didn't
to
do
DevCon.
that.
I traveled to DevCon to Bangkok, and so that was like an in-person experience, but I had to miss a week and a half of school for that, so still catching up.
Hmm. Yeah, I didn't do that. I just like full on self isolation. Just went into crypto. Never got back into school. Don't regret it one bit. I'll be honest. Still don't have a high school degree. I didn't drop out. I just never like finished school. is like the reality. And like no one's ever asked me. No one cares in crypto. Everyone's pretty open. I guess now let's get into base rollups. So how did you get from into MEV into based rollups? Like what was your sort of pipeline? And yeah, get into that.
Yeah, there's one thing, Justin Drake, one person. Um, he convinced me early on, as some like the base Phillips research was starting, that base Phillips would be potentially a very interesting kind of infrastructure researchy product. And I thought this would be a great way to kind of take my connection with Justin and some of my writing skills and just produce some things about base Phillips. And so I started this process, and I'd never even finished any research before I was contacted by my now co-founder Kaito, and we ended up launching a company together because we really hit it off. I mean, Kaito is amazing, and I think the thing that I learned pretty quickly was that like you can do this writing, you can like put out content, but without building something, you're never going to understand certain things about crypto. So I wanted to I wanted to know, and I really do think base rollups are just an incredible piece of technology from a research perspective, but also just they're a great product. That's why I made the switch.
Okay, so now let's get into like the base rollup stuff. So where exactly do we start? Or actually, let me explain my idea of a base rollup, and then you can sort of explain, add on, change misconceptions. So you have like this like DA
Yep.
layer, uh, uh, Ethereum, Celestia. We'll get into the Celestia stuff later, but you have a DA layer. Users directly submit their transaction data onto the DA layer. They don't have a sequencer. They don't like send their transaction to a centralized sequencer or a shared sequencer. Just directly have the sequencing of the DA layer. And then afterwards, you have these transactions that are already sequenced. And then all you do is do the proof stuff. Is that right? Is there anything I'm missing? Is that a base rollup?
Let me give you my definition, perhaps, and we can compare and contrast a little bit. So I think there's three things you need to be a base roll. The first is that sequencing, there's a sequencer auction that favors the base layer sequencer. So in Celestia's case, that would be proposers. Same on Ethereum, right? There's the proposers that can build blocks. And the second thing, which I don't know, maybe this is where we start to disagree, is that the block proposals for your base rollup need to be atomic with Ethereum block proposals. The way that you do this in practice is just by having your canonical layer 2 sequence be defined by a layer 1 transaction. So every layer 2 block is a layer 1 transaction. The mapping there. And then that means if the layer 1, the base layer reorgs, then so does your block. But it also means that you can do super fast interop between these two because there's no risk that one block gets, doesn't get finalized and the other does. So that's going to be maybe the definition that I would put on it. Is that, I guess that kind of aligns with what you're saying. I think the question of like the DA properties is maybe where we could start to put a different spin on it. But I'm curious to hear what you think.
Uh, yeah. I think let's get into like the Celestia stuff like last. So I guess now let's talk about sort of the proving. I know you talked about the prover being the valid block being the one that produces most value, which I thought was interesting, and then like pairing it up with the sequencer being the prover is like really cool. So talk about that, and then talk about like just like sequencing in general. Yeah.
Sure. So we can say we have an auction to choose the sequencer, but the that only gets you one thing, which is like who is the sequencer? The question is then how do they propose a block, right? And how do they broadcast this block? How do they construct the block? What are the rules about that? And then the details of the auction is kind of the other half of that discussion. So start with the auction. Our goal is to have so that what we need at the end of the auction is a kind of a list, an ordered set of proposers who have the unilateral ability to propose blocks. These blocks might be constrained by input from other sequencers, but there's ultimately a proposer. And that proposer is ideally the same as the layer 1 proposer. So the unilateral kind of sequencing rights entity on Ethereum is the current proposer. That's the ideal state on a base rollup. Now, it breaks down a little bit because the current layer 1 proposer might not be the kind of proposer that can sequence your blocks. Maybe they don't offer pre-confirmations, they don't have collateral, perhaps they don't even use map boosts. Maybe they have like liveness issues in the past. So you'd like to favor proposers that have pre-confirmation collateral, and that have like maybe they're running a full node anyway. And so the other part of this auction is like choosing which proposers would we like to favor. And the reason we don't just have a liveness failure when the current proposer is not the is not opted into all these things is because even though we skip over them in the auction, we can elect the proposer that comes right after them in the look ahead. So in Ethereum, we know 32 proposers in advance. And so we know basically if proposer number 5 isn't opted in, we can just ask proposer number 6 to sequence for blocks 5 and 6. And so the way this works in practice is that then you have a very complex auction where the winners are you want it to be some people, but you also want to make money from distributing sequencing rights. Like you don't want it to just be completely permissionless, or you don't make any MEV. And so the way that we solve this at Spire and Based Rollups teams have different answers for this question is we run a auction that is a kind of a pre-auction. It runs before all of the actual election. And what it does is it distributes these things we call tickets that just give a proposer the right to propose a block ahead of time. So maybe this happens 2 weeks in advance. You generate tickets and you distribute them. So you have kind of two separate steps. The first step generates a list of holders and their balances, and the second step elects them. That election step is where we add all of our opinionated rules about who do we want to be the sequencer. And then the key kind of requirement is that to propose a block, you must burn a ticket. So we kind of have an order of hierarchy. First, we want proposers with the most collateral. Then we want proposers with any collateral who are interested. Then we have proposers that are not involved at all. And last, we have proposers that are like known bad actors. And so this is kind of the order of hierarchy. We try to distribute tickets among these, considering their position in the look ahead. And at the end of the day, if there's no proposer opted in any place in the look ahead, then you just allow anyone with a ticket to propose a block. And that's an extremely configurable thing. So I say this, like we are opinionated about it, and we are, but we don't run a layer two. We give other developers the ability to launch their own layer twos. So if they want to customize that, maybe they distribute some of their tickets to solo stickers instead of distributing them through an auction. They can do that. That's like a one-line change. Super easy. And then the rest of the kind of pieces of the auction are flexible as well. So if you want to prioritize liveness, you can just give like a super permissionless things. You can say like you don't even need a ticket to propose. No tickets required. Or you could go the opposite route, which is we want to capture as much MEV as possible at the risk that we might have kind of times where there is no kind of live block. And so these are the kind of the two ends of the spectrum here. And I think that this is one of the most interesting parts about sequencing is that there's different design for election. But there's another side, which we call sequence constraints or sequence rules that kind of constrain what the elected block proposer can actually propose. So maybe this proposer is running pre-confirmations, they're spitting out blocks, and they're giving users a great 100 millisecond block time experience. And now we want to enforce that this proposer also provides censorship resistance. I think that makes sense. And so the way that we can do this is by connecting the proposer to other kind of, we call them inputters, right? Who essentially maybe called sequencers. It doesn't matter. In Ethereum, they're actually called kind of committee members, inclusion list committee members. What they do is they generate inclusion lists or some information that changes how the proposer's block has to look. This is defined by kind of the validity rules of the rollup. So you have to have a proof for that on the chain. And we don't have to get into specifics here, but one example might be kind of priority ordering. So you have the sequences in your block, must be ordered in a priority. One other one might be that you need to have signatures from 5 of 10 censorship resistance kind of committee members who say, my inclusion list has been satisfied by this block, and you can prove that. So it doesn't require like 2 rounds of communication. It's not consensus. And so there's always a trade-off, usually between liveness and censorship resistance. But the interesting thing is that you can allow apps to configure this as much as they want if you're on an app chain, choose wherever they want along that spectrum. So I think that's honestly kind of the basics of how I view Based Rollups on Ethereum is this kind of sequencing election. You do with an election, people do it different ways, and the sequence constraints. You can combine these two to get a really solid base rollup. But sequencing is not all there is, right? You need to think about DA. You need to think about like the execution and composability features, and that gets a whole another rabbit hole, like real-time proving and that the paper is like at layer and shared deposits. Right?
Mm-hmm. And I guess let's get more into sequencing. So you can sort of sequence your blocks however you like. And so my question is about, so you have what is the sequencing where like anyone can post any sort of transactions anytime? What is that called?
So people usually call this total anarchy or permissionless based sequencing, where there's no elected sequencer, just anyone who posts a block, then you're good to go.
Mm-hmm. And so with the sort of this ticket system, what is this system called? Is this specific to your work?
Yeah, so this is you can read about it in our late paper. Spire.dev is the URL. And we call it based ticketing sequencing or just a based ticketing rollup that uses that. And it's very similar to like execution tickets on layer one. Has a lot of the same properties. We just use it to kind of distribute those sequencing rights in a way that doesn't have to happen at the same time that you're electing proposers. Just kind of separate those concerns a little bit.
Hmm. Another really cool thing about sort of base rollups and being able to control like everything just about the sequencing is that you talk about sort of the deterministic function for determining like the most valuable block, and then like sort of other base rollups that have or other base sequencers can sort of agree like yes we want to add this block, and that like adds censorship resistance. Could we also talk about sort of the benefits of sort of custom sequencing from an app chain perspective? So like I guess now let's talk about not only one base rollup, but like having multiple and like composing between multiple base rollups. So like why are why is sequencing and like sort of app specific base rollups like cool? I'm also like a really big fan of this idea. And then yeah, so why app specific sequencing for base rollups and multiple base rollups?
All right, so I guess the I'll flip the question. Why not do an app chain? The only reason not to do an app chain is because app chains have a really massive problem, which is fragmentation, isolation, and complexity. Right? Those are kind of the big three. You're putting yourself at a massive disadvantage to your competitors if you have a 10 times higher user acquisition cost because users need to bridge to your before they use it. That is so annoying, so frustrating. And then for developers, there's more complexity, right? You can't access the oracles that you know and love because you need to get those redeployed before they're really usable for you. And so I think this is a big part of why AppChain, right? Because you can customize things. But now with base rollups, we can offer that composability. Let's talk about multiple base rollups though. So having one base rollup, maybe it's composable with a base layer, Ethereum. That's great, that's useful. But we also want all base rollups to be able to talk to each other, kind of do this layer two interop. And the way that we do this is with a very simple kind of ZK rollup construction, where for a proposed block to be valid, it has to kind of be checkpointed on layer one every layer one slot. So every 12 seconds, there's a layer one block. Um, and then during this kind of block, the layer two transaction that proposes the block needs to have an associated ZK proof that can be verified. And so the key constraint here is that this proof needs to prove things, full execution of the layer two. The EVM block, then you're just computing kind of the state transition function. Um, and so if you can do this for multiple base rollups at the same time, and then aggregate the ZK proofs, something like AgLayer, and these rollups have shared deposits like AgLayer, then you can do interop between these base rollups without ever touching layer one. In the absence of this kind of aggregated proving technology and shared deposits, you can still do interop between base rollups. You just have to kind of pass a message across the layer one. So you're getting layer one gas, which is painful. And that is kind of the key construction. Now, here's why everyone isn't doing this right now, is because you need fast proving to do this. And the reason you need that is because to put a block on chain, you need an associated ZK proof that can be verified on layer one. And that ZK proof today is slow to generate for an EVM block. If it's about the size of Ethereum, then that can be anywhere from like a minute to an hour is kind of the range that we're looking at. And that just is really painful because that means you need to create your blocks a minute to an hour before they get posted to Ethereum. And no one's doing that, right? That means every user would have to wait, whatever that proving latency is. And so driving proving latency down is really important to base rollups. And the kind of holy grail is what we call real-time proving, which is like roughly 200 milliseconds to prove a EVM block. The faster we can get there, the better. Now, we can do TE proving. It doesn't need to be ZK, but it has security issues, I think. It has some kind of complexity issues as well when it comes to like censorship resistance, but that's another conversation. And then, but what we really want is this real-time ZK proving. We can verify on layer one. It allows you to do seamless cross-chain kind of contract calls and other types of interop, with some other kind of technical changes to how the rollup state works. And so that's the key thing that we need. And so I said on Twitter like the sequencer is the prover, and that is like a proof statement from the perspective of layer one because the same person proposing the block is also providing a proof, whereas like on Tycho or some of these rollups that's not the case. They have like a prover network that generates this proof instead of the proposer. But one thing I should clarify is that like off chain, it does not have to be the proposer who generates the proof, even though it might be in practice. You could outsource this proving to a prover network, of specialized zk provers, maybe using succinct new product. So you could kind of use the existing infrastructure that we've built up for traditional zk rollups, and then use those for a based zk rollup.
Yeah. The sort of re-simplification of rollups that like base rollups just like sort of has makes interop way easier. And I guess let's talk about why this isn't the case for like the sort of optimism, arbitrum, sort of settled smart contract rollups, and how like base rollups sort of like skip all that complexity and in return sort of just get like interop. Like why can't I get like these features on sort of normal classical smart contract rollups?
So the key thing that I want to highlight here is that if you're a non-based rollup, what you can't do is know the state of layer one because you're not kind of doing shared sequencing with that state. And so the Ethereum layer one sequencer could change the state independently of what your layer two sequencer preconfirms. So then you'd have a desync here. That's why you have some delay on existing rollups. Now that delay could be one block, it could be pretty short. But that means you're not able to preconfirm user transactions any faster than Ethereum slot time. And so the goal with base sequencing is not actually anything to do with the just the phrase shared sequencing. It's really with aggregated proving or just shared proving in general. I like to call it coordinated proving, where you're doing proving for one domain with knowledge of the sequence or state of another domain, and maybe doing two proofs at the same time for different base rollups. And then when you put that all together, then you can do this coordinated proving to kind of transfer funds between chains instantly. You don't need to wait for a long withdrawal time. There's nothing stopping existing rollups from doing it once they have extra proving, except that you're just going to have a desync between the layer one canonical state and the layer two canonical state.
So like the reason why base rollups with this like sort of having the sequencing is the sort of is like Ethereum is the base layer, and the proof aggregation can be also on the base layer. And so like if you have your base rollup, you can like, you're looking into Ethereum for DA, but you can just like look into other people's blocks and then compose that way like super easily. And so like this like removes a lot of the like interop problems. It removes sort of asynchronous composability. All of a sudden you have like synchronous composability. All of a sudden like these blocks on Ethereum are like I guess like super blocks is like a way to describe it.
Sure.
And then you have like the sequencing and then the proof aggregation, and like this is way more better and way more exciting. It feels like a sort of like Ethereum is now the super chain. It has like it does the sequencing, it does the proving, it does the ordering, and it's like this is way better than like the optimism model where they're like we're the super chain, and then Arbitrum is like but we're the super chain. It's like Ethereum is the super chain, like going back to basics, and like rollups just like bring this. So like I just like love this idea.
100%. I mean, I tweeted this a while ago. It was like the concept of using a shared sequencer to interop between layer twos has been around for a while, and it'll probably work. Like I don't doubt it will. But the other thing that base sequencing has an advantage on over a shared sequencer that can offer like this synchronous composability is that first of all, we can attach to layer one, and layer one is just massive today, like objectively, very valuable to compose with. And secondly, it's also the in a position of credible neutrality from the perspective of layer twos. They already choose to settle on Ethereum, so they have kind of some alignment. but they also are, I believe would be much more willing to use that shared sequencing layer that is Ethereum instead of like opting in to one of their competitors' kind of code stacks. So if Optimism launched a shared sequencing protocol, then the the downside of this for Arbitrum would be that like your biggest competitor is running code that you depend on. And so if Ethereum is providing this service, and it's just a credibly neutral way for these teams to coordinate, even if they're competitors, you grow the pie,
Yeah.
I guess is the way I would say it.
Mhm. And then I guess now let's talk about pre-confs. So are pre-confs needed for base rollups? Talk about the user experience and sort of the block times, verifiability, all that stuff with and without pre-confs, and then sort of we'll talk more about like if you have single self finality pre-confs, you might not need them. Blah blah blah. So talk about pre-confs.
Oh, you still need them. Um, the thing I'll say about base rollups is they don't need pre-confs. Techo is a base rollup. It runs on Ethereum layer one, um, and does not have pre-confs live. And so it's just an objectively false statement that base rollups need pre-confs. Now, to get a good user experience and to reduce costs, pre-confs are really nice. Um, and one thing I'll just put out here is that every layer two that has a centralized sequencer has been doing pre-confs for as long as they've been running. There's kind of an unsafe head of the layer two that the sequencer just promises before committing to kind of batching that onto Ethereum. So I like to call this the batching time. It might be an hour to 12 hours kind of range. It depends on the rollup, right? Um, so everything in this batching kind of range here is not a real block, right? It's just a pre-confirmed block. Sequencer is giving you a pinky promise that the blocks will look like this when they actually batch them, but there's nothing stopping them from doing something else other than reputation. And so layer twos are doing pre-confirmations today. It's not a novel concept. We know how to do pre-confirmations. Um, Now we want to take the same concept and apply it to base rollups. So people say base rollups have a block time of Ethereum. That is wrong. Base rollups have a batching time of Ethereum as their minimum, just like any other rollup. The actual block time can be whatever you want it to be. Could be 1 millisecond. It's just up to the rollup sequencer. So the key kind of innovation with pre-confirmations is that we can do a dependent slopestyle auction, is what we call it. We kind of make these mini blocks, shreds, chunks, whatever, and then package these up, include user transaction in those. The sequencer sends that out, and then makes a crypto economic commitment to that shred that it will be included in order with all the other shreds to form like this final block that they include on chain. You can force this on chain. You can enforce it off chain as well with economic properties. So the key thing that we want to enable here is a user experience that feels really fast because base rollups without these kind of pre-confirmations will feel what Ethereum feels, so not very fast. So this change is I think pretty important. Now, pre-confirmations are such a complex rabbit hole that I think people lose sight of the big picture. Pre-confirmations are not that hard. You just put out these chunks, these unsafe blocks, and then turn them into a safe block by bundling them all together in order. People have tried to do what we call streamed pre-confirmations. Those work a lot better for inclusion and not execution. And we don't honestly know how exactly dependent self-side auction protocol will look on Ethereum, but there's people who are doing it. So BuilderNet and Tool, who are two independent products, both have kind of the ability to wrap builders in TEs. Tool is especially focused on pre-confirmations. So they have 1 second blocks that are basically what I'm describing, where they just have these little chunks before a full Ethereum block gets put out there. So they're focusing on layer one, but thankfully, improvements to layer one sequencing help base rollups directly. And so, if they have 1 second pre-confirmations for Ethereum transactions, it's just like having 1 second pre-confirmations for base rollups. Now, replace 1 second with 100 milliseconds, and you could understand how kind of this technical innovation will dramatically improve kind of the base rollup user experience.
Mm-hmm. The sort of like pre-confs are sort of like real and they exist, but currently right now it's only like the centralized sequencer that like Coinbase runs for base, and so they like give you like the trust me bro, we'll like add you in the next block.
Yeah.
But how do
So
pre-conf go for it?
Yeah, I think that's a true statement. It's just trust me, bro. But pre-confirmations for base rollups, I think it's much less about that. Like Justin will say this, like crypto economic guarantees. That's what Justin likes, is having that collateral. I don't think it really matters that much. Users don't care. The reputation of Coinbase is greater than any individual validator's stake. So like 32 ETH is a lot of money, but Coinbase reputation is worth way more than that. And so at, at some level, I think it's kind of it's almost a bit of a bit of a straw man to some degree. Now, the benefit of pre-confirmations is really that your user experience improves by a ton. Um, and so for just a retail user, it gets better. It's also better for traders for a reason we can get into sooner if you do dependent self-start auctions and not independent ones. Um, and so I think those are really the real reasons, not these, I guess, the alternative way you could look at it.
Yeah. My question was about, so Optimism has this single signature, and so they're able to give out pre-confs. But how does a base rollup, which lets like a sort of in total anarchy, anyone submit transactions, anyone sort of be the sequencer, I guess. How does
Yeah.
pre-confs look in a base rollup land? And also, I guess you already answered the question, which is like, do you really need like a sort of a certain like stake threshold, or like what would it be, like security, like a safety deposit for these pre-confs? I guess you already like answered that. But how does pre-confs look like in base rollup land?
Sure. So total anarchy base sequencing is not compatible with pre-confirmations without some really important changes to how the layer one does sequencing. And the reason I say that is because if you're doing total anarchy, you're not sure who the block builder will be until after they've built a block. And you can like you know who the layer one proposer will be, so you know who has like the final say. So they can offer pre-confirmations, and that is like such a true statement. But you need opt-in from every proposer to get reliable pre-confirmations. And unfortunately, that's just not something that is practical for the short term. And so if you change your sequencing rules to say we know the proposer ahead of time, and it's only proposers that are opted in that can be the sequencers, you can skip over some blocks and do some tricks, then the you can get like 100% near 100% uptime of pre-confirmations without but you lose this kind of permissionless total anarchy property, which I think is perfectly fine because even Ethereum blocks are not total anarchy.
Mhm. And so I guess now let's talk about the uh or actually let me talk about my side of sort of pre-confs and sort of my sort of pitch towards Celestia. So I think you got this right, which is about the block times where let's say Ethereum has what 12-second block times, right? But for base rollups, that wouldn't be the block times. That would be the batch times, which I think is like a very important like misunderstanding.
Yeah,
But if you could squeeze the block times lower, then you can have sort of less trust when it comes from the sort of sequencing side
kind
to
of.
the like hits the block. Because if you have like a like let's say you have like Bitcoin block times, whatever, 10-minute block times, then you have to trust the sequencer for those trust me bros for 10 minutes
Right, unless
versus
there's collateral.
for of unless there's
Sure.
collateral versus the sort of if you on Ethereum land that would be 12 seconds. You have to trust them until the data hits the chain. And so if you have a DA layer with
Yeah,
smaller blocks or smaller block times, then that trust window gets minimized. So like you're shaking your head. Tell me.
I agree. Like having a shorter window is better because there's less opportunity for something to go wrong, first of all, and also for some malicious actor to take that step. I don't think that actually matters in practice. I think the best reason to have shorter block times on the layer one is because then you rotate the sequencer faster, and that if we all know if you rotate the sequencer faster, then that reduces LVR for kind of liquidity providers and AMMs. And so that's just a really important kind of thing to understand. And the second thing is that the faster you rotate the sequencer, the more sensor persistence you have. And so yeah, I believe that those are kind of the two things we should prioritize. That kind of like period of time where the block is not safe, it's just unsafe pre-conf blocks. Um, something we need to care about. But I think we've seen in practice that like users don't care. Like, you're waiting. I don't know exactly the numbers. It's like I think it's like an hour on Optimism mainnet. Users don't care that their blocks are unsafe for an hour because it seems safe to them, right? Their RPC or their wallet is telling them that it's all good. Does that make sense? Like I don't think it just provides any commercial value to rotate sequencer faster, except for censorship resistance and that kind of robustness property as well.
Well, so here's my perspective on this is that sort of like we want trustless systems, and so like it's better to like not trust the bank 100% versus like a blockchain where maybe you have to trust the proposer for inclusion. And so like having less trust, like minimizing that window of trust is like important. And so although users don't care, I think overall like people use Solana and like they just like want to like use meme coins. And so I think if you apply that argument, you could also be like, but Solana's like has these beefy nodes and people don't care. So like where is the line right there, if
Well,
that makes sense?
I think that's a different discussion. So hardware costs are a very different discussion. So I don't want to get into that. I'll say like, yeah, you're right. We want to build systems that have kind of the trust assumptions that we like. I just think that the practical benefits of rotating your sequencer faster are not necessarily that kind of window of trust. Just because like it's interesting. It's not really like the how fast you rotate sequencer, but it's also like the time to finality and the reorg risk as you get closer to finality. And so that matters even more, I think, to users who care about that trusting the sequencer. Another thing I'll say is that if you do have collateral, which pre-confirmation systems on Ethereum plan to, or use TEs, then you're not like trusting the sequencer not to screw you over. You're trusting them not to screw you over, or they take some financial and reputational penalty. And so I think I just want to make it clear that the trust assumption is not kind of like unilateral.
Yes, but if your argument is about practicality and like users don't really mind sort of these like trust assumptions, whether it's like instead of getting Ethereum security, you sort of use sort of pre-confs with like some little bit of stake. So like users don't care, but it still matters. And so I'm not sure if the practicality argument is like super solid, if that makes sense. Did I make that clear?
I'm not sure I entirely understand. You're saying that the it is it is better, quote unquote, for our priorities. And I'm also saying that like practically, the the trust assumption is not that much better than what you'd be getting otherwise. So like moving from 12 seconds to 1 second is not 12 times better, right? There's some increase in kind of our arbitrary uh, objective function here, which is how much better is it? But I think that because you can do things like economic kind of commitments over this time frame, and you can do things like TEs that like are trustless with some potential risks, then you are in a position to kind of change the way that these trust assumptions work at any time scale.
Okay. So my argument is practically sort of users don't really care how the thing works. And so in the background, it's more ideal to have sort of trust instead of being longer block times, sort of have all of these trust assumptions, whether it's trusting the sequencer's reputation, whether it's like the stake, to have less of that during that period. And so like ideally shorter block times would be better. That's only I would say ideally, but in like reality, like users like don't care. This is like the reality. So like I understand
Yeah,
where you're coming
maybe.
from.
Yeah, I think the reason I like shorter block times is for censorship resistance, which is traders care about a ton. Even application designers do because you can run on-chain auctions instead of off-chain ones.
Mhm. I guess now let's talk about sort of the construction of these base rollups. So, do you think? I guess right now there's going to be EVM based rollups that can like sort of compose with each other. Do you imagine a world with different VMs? How strong do you think app chains are going to be? Is there an incentive for sort of, let's say like SVM sort of base rollups like happen? Is there a super big incentive to have your own based app chain rollup versus just like a super fat SVM EVM rollup like we see in like traditional L2 land, where it's like people don't really like this app chain stuff, or base rollups. They do give you the like sort of seamless interoperability and the synchronous composability. But if you can like scale a giant fat base rollup, does that how much benefit is that? Do you think we'll have a whole bunch of fat base rollups, or like a super specialized app role based app based rollups? Anyways,
We call them based Appchains. Yeah, I don't know for sure. I honestly am not sure. I think that Appchains are likely successful if we can fix the off-chain costs, which is expensive to have an app chain because you need that Explorer, that RPC, all these things that people charge that kind of branding premium on, and it's kind of idiotic. I think market forces will drive these down, but the market's unfortunately not very fast. And so the other thing I'll say is like for EVM and SVM, other kind of alt VMs. I think alt VMs are overhyped for the most part. I believe EVM is like and I know it's a hot take, but I believe EVM is like the most developer friendly, especially because we just have 8 years of developer tooling and education content built around that. Um, Now, I will say that there are some cases where modifying the EVM with precompiles, that's the precompiles, um, or just upgrades to the EVM and alt VMs can be what developers want. And so, yeah, I think we'll eventually have, and we have plans on our roadmap to support things like the SVM and other kind of VMs within sequencing. So, like the base sequencing only changes the sequencing. You can still do whatever you want on the VM side. If it's, you know, if you want to do optimistic rollups, then you could. You want to do ZK, you could. And you can, of course, change your VM to be whatever you want. You could even run like what Cartesia is doing and have a RISC-V VM. You're not limited to EVM or kind of SVM or any of these kind of traditional blockchain VMs.
another thing is you talk about base rollups having network effects. Can you just talk about that?
Yeah, so base rollups, I think every computing environment in context of blockchains has these network effects, right? The more that's on one composable layer, the better, right? You can use liquidity is kind of the key network effect. There's also other sorts of things for developer experience. Base rollups have a massive network effect because they include Ethereum in their composable layer, um, and they also have I think, a pretty substantial network effect because the more base rollups there are, then the lower marginal cost for each new base rollup. So there's like a relatively, let's call it a linear on-chain cost, like layer one costs for base rollups. And so as you increase the number of base rollups, then you can increase the number and like throughput and scale of these base rollups at a rate that is faster than the on-chain layer one cost grows. So you add 100% more base rollups, and your on-chain costs might increase by 10%. So you just have more capacity for the same cost, which is increases your network effect, right? It's really nice. So that's one reason I say base rollups have network effects. And then there's all sorts of other things that we could get into. But yeah,
Mm-hmm.
we are running up on time, so should try to get a
Ooh,
few
yeah.
more things in about Celestia and Ethereum, then we can close, I think.
Is there? I guess let's wrap it up for the last 5 minutes. But is there any uh, misconceptions that people have about base rollups? Any sort of ideas that you want to like say? Any cool things happening? Sort of just like anything you want to like talk about at the end?
Yeah. I think the biggest misconception about base rollups is still that they lose MEV. They're just giving up MEV. That's not true. I have so many tweets explaining that I won't reiterate it here, but it's just wrong. But there's other misconceptions too about kind of what is a based rollup actually. What kind of boxes do you have to check? Is based espresso? Espresso's kind of base sequencing product. Is that a base? Is that actually base sequencing? I don't think so. Are the kind of the centralized sequencer layer twos, are they ever going to become based? What's the kind of timeline for these converting to being based rollups? I think there's some of the open questions. So I want to close this by saying that Spire is starting our content month, right? December is going to be a huge content month for us. We have like a Telegram chat with some kind of invite only writers who are working on base rollups. happy to invite any listeners of this podcast to just DM me on Twitter. And we're building out kind of a content library just to make it easier for people to learn about Based Rollups, about Spire, about kind of the unique properties here. Because I think people say the most bullish thing for Ethereum is to be understood. I think it's true for Based Rollups as well. That Based Rollups just don't like they're so much better once you get to understand them, but people just don't care enough to actually learn. And it's up to us to convince them why they should care.
Yeah, you are probably the singular person who pushes Based Rollups the furthest. And like every single day, I'm just like the Based Rollup guys talking about Based Rollups. I love Based Rollups, by the way, too. But thank you so much for hopping on. I am also a part of the Telegram group and am a Based Rollup evangelist. So
Cool.
I would like to see sort of these. I would like to see Ethereum be the super chain. Anyways, thank you.
Heck yeah. Thanks, man. Have a great day.
Mhm.
Cheers.